My name is Danish Iskanda, and today me and my group gonna present about the welding distortion, welding defect, and how you're gonna improve your welding. So before I jump into anything else, I'm gonna give you a definition of what is welding defect. So basically, welding defect is when your weld surface have an imperfection or discontinuities on your weld surface that will cause the bad result when you weld. So that is what welding defect mean. So how about welding distortion? So welding distortion is happen when after you welding they have unwanted physical change that happen on your weld. So it will cause a bad result or something really bad happen. So these are my group will present to you what is distortion, what is welding defect. So let's check it out.
Hello, good morning, sir. My name is Muhammad Akmal Azwan. My number metric is 05 DKM 20F2018. Today, I want to talk about welding defect. There are various types of welding defect. First, undercutting. Unfilled groove present along the edge of the weld. The cause is improper welding technique, excessive welding current, and incorrect manipulation of electrode while depositing the weld bit. The remedy is use large electrode. Use moderate current and move the weld torch slowly over the workpiece. Next, porosity. Cavities or pores caused due to entrapped gases in the molten metal during the solidification process. The cause is contaminate gases in the molten metal. Inadequate shielding. Unstable arc, small arc gap, poor welding technique. The remedy is proper selection electrode and filler materials, decreasing the speed of the welding torch. Next, incomplete fusion. The cause is improper penetration of the joint, wrong design of the joint, incorporating incorrect welding technique. The remedy is supplying low electric current that required, cleaning the joint property. Next, overlapping. This consists of metal that has flowed on the parent metal without fusing with it. The defect is due to contamination of the surface of the parent metal. Spatter. Stick to the welding surface. That cause high welding current, long arc, incorrect polarity of the arc blow, improper gas shielding. Remedy: decreasing the welding current and arc length, using arc having correct polarity. And lastly, incomplete penetration. Incomplete penetration occurs when the groove of the metal is not filled completely, meaning the weld metal doesn't full extend through the joint thickness. The cause is there was too much space between the metal welding together. You're moving the bed too quickly, which doesn't allow enough metal to deposit in the joint. You're using a too low amperage setting, which result in the current is not being strong enough to properly mate the metal. Improper joint.
What is distortion? Distortion is any unwanted physical change or departure from specification in a fabricated structure or component as a consequence of welding. First is angular distortion. Weld tends to be wider at the top than the bottom, causing more solidification, shrinkage, and thermal contraction. For double VH butt weld joint, it depends upon loadless and load gap. Fillet weld joint depends upon flank thickness. Depends upon type of joints, weld pass sequence, thermomechanical material properties, width and depth of friction zone relative. Second is longitudinal shrinkage. Shrinkage in the direction of the weld axis. Cause of longitudinal shrinkage is preheat or fast cooling problems. Second is shrinkage stress in height constraints areas. Preventions. Weld towards areas of less constraints. Second, weld short length. Third, preheat to even out the cooling rates. Fourth, flattening press checks clamps should be used. Third is transverse shrinkage. Shrinkage running into or inside a weld transverse to the weld axis direction. Cause of transverse shrinkage is weld metal hardness problems. Constraints apply to weld joints. First is butt welds. 1.5 to 3 mm per weld to 60 degrees V joint, depending on M number if runs. Second is a fillet weld. 0.8 mm per weld where the leg does not exceed 3/4 plate thickness. Fourth is a rotational distortion. In this, sheets being butts will either come closer to each other or the distance between them is widened. Depends upon thickness of parent material, temperature difference between a molten pool and the unheated parent, speed of welding, heat source. Fifth is bowing or longitudinal bending. Weld line does not coincide with a neutral axis of a weld structure. Amount of distortion depends on shrinkage moment and resistance of the member to be bending. Six is twisting distortion. Twisting is due to low torsional resistance on thin materials. When a weld is laid along the center of a member, the weld area tends to shrink and become shorter.
Thank you to Akmal and Nur Naziman for explaining what is welding defect and what is welding distortion. So now we're gonna jump into how we're gonna minimize a welding distortion. So let's check it out.
So my name is Oscar Rangat, and today I'm gonna tell you how to minimize distortion. Number 1, do not overweld. The more metal placed in a joint, the greater the shrinkage forces. Correctly sizing a weld for the requirements of the joint not only minimize distortion, but also save weld metal and time. The amount of weld metal in a fillet weld can be minimized by the use of a flat or slightly convex bit, and in the butt joint by proper edge preparation and fit up. Number 2 is use intermittent welding. Another way to minimize weld metal is to use intermittent rather than continuous welds where possible, as in figure 3 to 7c. For attaching stiffness to plate, for example, intermittent weld can reduce the weld metal by as much as 75% yet provide the needed strength. Number 3. Use as few weld passes as possible. Fewer passes with larger electrode, figure 3 to 7d, are preferable to a greater number of passes with small electrodes. When transverse distortion could be a problem. Shrinkage caused by each pass tends to be cumulative, thereby increasing total shrinkage when many passes are used. Number 4 is place weld near the neutral axis. Distortion is minimized by providing a small leverage for the shrinkage forces to pull the plates out of alignment. Figure 3 to 7e illustrates this. Both design of the weldment and welding sequence can be used effectively to control distortion. Number 5 is balance welds around the neutral axis. This practice, shown in figure 3 to 7f, offsets one shrinkage force is another to effectively minimize distortion of the weldment. Here too, design of the assembly and proper sequence of welding are important factors. Number 6. Use backstep welding. In the backstep technique, the general progression of the welding may be, say, from left to right, but each bit segment is deposited from right to left as in figure 3 to 7g. As each bit segment is placed, the heated edges expand, which temporarily separates the plates at B. Number 7 is anticipate the shrinkage forces. Presetting parts at first glance, I thought that this was referring to overhead or vertical welding position, which is not the case. Before welding can make shrinkage perform constructive work. Several assemblies preset in this manner are shown in figure 3 to 7H. The required amount of preset for shrinkage to pull the plates into alignment can be determined from a few trial welds. Number 8 is plan the welding sequence. A well-planned welding sequence involves placing weld metal at different points of assembly so that, as the structure shrinks in one place, it counteracts the shrinkage forces of weld already made. An example of this welding alternately on both sides of the neutral axis in making a complete joint penetration groove weld in a butt joint, as in figure 3 to 7K. Number 9 is remove shrinkage forces after welding. Pinning is one way to counteract the shrinkage forces of a weld bit as it cools. Essentially, pinning the bit stretches it and makes it thinner, thus relieving by plastic deformation the stresses induced by contraction of the metal cools. But this method must be used with care. Number 10 is minimize welding time. Since complex cycle of heating and cooling take place during welding, and since time is required for heat transmission, the time factors affects distortion. In general, it is desirable to finish the weld quickly, before a large volume of surrounding metal heats up and expands. The welding process uses types and size of electrode, welding current and speed of travel, thus affect the degree of shrinkage and distortion of a weldment. Thank you. That's all from me today.
We have done our presentation. As you can see, we have a ton of way on how we're gonna minimize the welding distortion. We have 10 ways to minimize the welding distortion. And what is the cause of distortion? We have 6. Why the distortion happen? And another 6. What is welding? What does welding defect mean? So, hope you get from this presentation and learn from our presentation. And thank you for listening and pay attention. Thank you, and that's all from our group.
Cause you make my earthquake, make my